Okay, this next section now deals with derivatives of hyperbolic functions. There's a theorem on 518 that we're going to base a lot of this on, but not only that, you're going to be asked to remember or be able to use the sum of two angles, difference of two angles, identities. Those are found in the cover on the cover sheets of the textbook to help remind you this when we go through this. So an example of this is find the derivative of y equals such x plus 1. We're going to make u be x plus 1, which means du is 1. And according to the theorem 518, the hyperbolic secant of u is defined as the negative secant of u such u then u times u prime. So we go ahead and replace, well, the u prime is u. I should have probably put the x plus 1, but I want to emphasize how that 1 was put in there. We just replace the u with x plus 1, so we get negative such x plus 1, then x plus 1. And that's your answer for that. For the next, we're trying to find the derivative of the natural log of the sine shin of x, or the hyperbolic sine of x. So again, using that, we find that the derivative is defined as 1 over sine of x using the natural log derivative ideas theorem that was associated with that, using 1 over shin x times the derivative of shin of x, and that is equal to cosh x, or hyperbolic cosine of x. Multiply these together using cosh x over sine x, which is coth x, just like cosine over sine is cotangent. So those two aren't too bad. We get into something a little more involved, like number 19, in which case we take the natural log of tan of x over 2, and we want to find the derivative of that. So we're going to let u be the tan of x over 2, which means that u prime is the secant squared, or sec squared, u to u. In this case, since u prime then is going to be sec squared of x over 2 times 1/2. So that's going to give us sec squared of x over 2 over 2. Then we plug that in here. So we have 1 over, so we have natural log of tan u prime was 1 over tan u times that, which we said is going to be this. We plug in this stuff there, and we get 1 over tan x over 2 times this thing right here, which is what we found that to be equal to. And then we go ahead and multiply it across. So this gives us, well, first of all, we're going to go ahead and change this to cosh over sine. Kind of like what I like to do, and probably you did this too when you did identities and trigonometry. You change everything over to sine and cosine. Same thing here. Secant squared is 1 over cosh squared, or cosine squared hyperbolically. The 2 stays in front here. These 2 cancel out to leave you 1 cosine on the denominator, so that's 1 over 2 hyperbolic sine x over 2 times hyperbolic cosine x over 2. And since, according to the identity, 2 times the sine of u cosine u is the sine of a double angle to u, then same works for our hyperbolic equivalency here. Replace u with x over 2, and we end up with x for this, for sine of x, sine, or hyperbolic sine of x, and plug all this in, and we get 1 over the shin of x over 2, cosh x over 2, and that's going to give us then according to what we just did up there, gives us the shin of x, and 1 over that, we said this was equal to this according to that right there, and that is going to then give us cosec of x. So, mathematical manipulation. This entire school year has been about mathematical manipulation. Your mathematical skills were a little weak coming in. You guys have really grown at this. Now this is going to push you even farther into a semi-familiar area of trigonometric identities, but now throwing in the hyperbolic equivalency to it, which is not that much different. In fact, the only thing different is basically putting an h in there. Follows the same patterns except for what the identities are defined as from a hyperbolic point of view. So, go ahead and do the practice problems and have fun.